Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to calculate the molar solubility from the Ksp value. Okay, so the first thing you need to do is for whatever element or compound that you're given, for this case we're going to do lead 2 chloride, and we're going to be doing iron 3 or iron 2 hydroxide for our examples. First thing you need to do is write out the dissolution equation of the compound breaking up into its ions. So for this one, it would be PbCl2 solid going into Pb2 plus aqueous plus 2Cl minus aqueous. So that's your first step. Your second step is to do an ice chart, because you have to figure out how much is actually going to dissolve, right? So you need to know what your initial amounts are, what your change is going to be, and you have to figure out what the amount is going to be at equilibrium. Okay, so you do your ice chart, and so initially we're going to ignore any solid, because again, when you're doing your ice chart and you're doing anything that deals with an equilibrium, your solids and your liquids are not going to participate. They're not going to be part of the expression, because the concentrations don't change over time as the reaction occurs. So we're going to ignore the PbCl2, and we're going to look at these two here, these two species. So to begin with, it doesn't dissolve at first, right? So at the very beginning, none of it dissolves. So we're going to have 0 here, and we're going to have 0 there. Now for the change, you're going to have a certain amount of your PbCl2 is going to dissolve. So for every 1 amount of this, you're going to get, it's a 1:1 to 2 ratio here. So whatever you lose here, right, for example, it's going to be, let's say, minus S. You're going to gain that same amount in this part right here. So this would be plus S. And since it's a 1 to 2 ratio, this would be 2S. Okay, so that's the change. And then what you do is you add these together, get the equilibrium. Again, we're going to ignore this. I only wrote the negative S so you could see the stoichiometric amounts here. So you're going to lose an S amount here, and then you're going to gain an S because it's 1:1, and then it's 2S because it's 2:1, or 2:1 here. Okay, so now for the equilibrium expressions, we're going to ignore the solid, and this is going to be plus S, and this is going to be 2S there. So now we can set up our expression for the Ksp. So Ksp is basically the equilibrium constant for the dissolution, right? So it's going to be the same thing, where it's going to be the concentrations of the products over the reactants, but here it's a solid. So basically it's going to be equal to the concentration of Pb2 plus times the concentration of Cl minus, and because there's a 2 here, it's going to be squared. So that's our expression. So now all we need to do is put in the equilibrium expressions in terms of S into here. So then this is going to be equal to Pb, that's S. So we're going to put S in there, multiplied by this squared, that's going to be 2S. So it's going to be 2S squared, and then that's going to be equal to S times S, 2S squared, that's going to be 4S squared. So S times 4S squared. and that's going to be equal to 4s cubed. Okay, so now we just need to know what the Ksp value is. So the Ksp value is 1.17 times 10 to the 5th. So this is 1.17 times 10 to the negative 5th. And that's going to be equal to 4s cubed. Divide both sides by 4. Okay, and then you get s cubed is equal to 1.17 times 10 to the negative 5th divided by 4. And then you're going to have to take the cube root of each side. And then that'll give you s is equal to 1.43 times 10 to the negative 2 molar. So that's the amount that's going to dissolve in water for this salt here. Okay, so next is iron hydroxide or iron 2 hydroxide. So let's prepare for that. Okay, so I'm going to erase this to give myself some room. Okay, so same thing with the iron. We're going to have to write our equation here. So iron hydroxide, iron 2 hydroxide, solid is going to dissolve and it's going to become iron 2 plus aqueous plus, and then we have 2 hydroxide ions, so it's 2 OH minus aqueous. And then we're going to do our ice chart again. So we're going to do ICE. So we're going to start with a certain amount. So we have initial amount. So whatever that is, we start with a certain amount here. And initially we're going to have 0 for our iron 2 and for our hydroxide, because at the very beginning nothing dissolves. Over time it's going to eventually change. It's a 1 to 1 to 2, so whatever we lose here is going to be negative s. Whatever we gain here, because it's 1 to 1, must be a positive s. And since it's 1 to 2, this will be plus 2s. And then again at equilibrium, this is going to be plus s and then plus 2s there. And then so at this point, now that we have our equilibrium amounts of our ions in terms of s, and we can solve for the solubility, the molar solubility of this substance here, iron 2 hydroxide, by setting it equal to the Ksp. So we'll say, okay, so the Ksp is equal to, again, it's going to be the concentrations of these two. So iron 2 plus times the concentration of OH minus raised to the second power because of the 2 there for the coefficient. And then we just put in our equilibrium value. So again, this is going to be equal to s multiplied by 2s squared. And again, it's going to be s times 4s squared, which is going to give us 4s cubed. And then so now we need to look up the Ksp for iron to oxide or hydroxide. Iron to hydroxide is 4.87. 4.87 times 10 to the negative 17, I believe. Negative 17, yep. And so now all we need to do is solve for S. So we'll divide both sides by 4. And then we're going to have to, this will cancel out, then we're going to have to cube root both sides, right? Cube root both sides, get rid of S. And then when we do that, we get 2.30. So S is equal to 2.30 times 10 to the negative 6 molar. So this is the molar solubility of your iron to hydroxide. I hope this was helpful. I hope you enjoyed this video. If you like my videos, please like, share, subscribe, hit the notification bell, and make a comment in the comment section. Thank you very much for joining me, and I'll see you next time.